So guys, let's continue. So yesterday we have completed route-based VPN, right? So if I'll talk about yesterday what I have started, the categories of the VPN. So we have two categories. The one we have route-based, and second we have policy-based. That is what? Policy-based. Okay. So yesterday we have seen in the route-based VPN. Okay, so the decision was taken by router was taking the decision based on what? Routing table here. Okay, so today in policy-based VPN, what we have to use? We have to use ACL. We have to use what? ACL. Okay, so let's start. Now, so let's consider I have site A. This is site A, and this is site B, and we are connected over the ISP. Okay, so this is we have. So this IP is about 11.1, and consider this is about 15.1. We have configured default route into this direction. In this direction, we have default route, and here again, what we have? Default route. So because of default route, we have reachability. Okay, so this is about 0/0 we have, and in this again 0/0. Behind this site A, we have LAN A and we have a LAN B. So LAN A is about, let's consider 1.1.1.1, and this is about 2.2.2. Okay. So yesterday, I think that is there or not? Yeah. Yesterday we have seen this. Okay. You remember yesterday I have created one tunnel. Okay. And there was a tunnel interface. In route-based VPN, we have tunnel interface, but in policy-based VPN, we don't have any concept about tunnel-based concept. That is different. Okay. So now in this, we have seen, okay, this is my 16.1 and this is my 16.2. And if I have to configure on a default route or a static route, let's talk about the static one. I have to ping from this one to this one here. There is a possibility, might be, let's consider on this here, I have one more and one more LANs we have. So this LAN is about 1.1.1.1, and this is about 2.2.2.2. The condition is, okay, if traffic is traveling, okay, or if there is any communication between LAN A and LAN B, okay, then only it should be secure. But if you are talking about 1.1 and 2.2, this is again LANs, okay, behind the same site only, but that should not be protected here, okay, or that should be travel via ISP. I don't worry about that. Okay, so in that scenario, in this here, so what you would mention in the static routing, because we need a static routing for the 2.2.2, am I right or not? So what I'll mention in the static routing, 2.2.2.2.0/24 via 11. Why 11.2? Why? Because I just want my exit interface, this one. And who's my next stop on this side? 11.2. But if I'll talk about in this scenario here, who's my static route? Who's my 10.2.0 via 16.2? So then first look up, let's consider I'm just doing ping from to the 10.2.2.2, 2.1 to 10.1. So whose destination? 2.1. It would look into the routing table. Do I have any reachability? Yes, I do have. How to reach? Via 16.2. Do we have any connectivity with 16 network? Let me check once again. Okay, this is known as recursive route lookup here. So do I have any reachability with this 16 dot network? That yes, that is there, that is down. So do I have any reachability with this? Oh yes, I have. And how? Tunnel interface 0. So then your data would goes via tunnel interface. For 1.1, if I'm using a ping with another 2.2.2.2 another loop back as a source of 1.1.1.1, then it would check into this one. Do I have any reachability with 2.2.2? Yes, I do have. How? Via 11.2. Do I have any reachability with 11 or how to route to 11 network? Let me check it out. 11 network. Okay. Which interface? ZC. So this is the concept about route-based VPN here. Okay. So based on the routing table, the router is deciding the traffic should pass through the tunnel or it should pass through the without tunnel. The tunnel is secure, correct? In that we have cryptographic methods that we will discuss today. Okay. How we will enable, that is not the concern. Right now the concern is this is secure. How, that we will talk about. Clear? But today now the second concept is here. This is my policy-based VPN. Which concept I'm using? Policy-based VPN. So in policy-based VPN, let's consider we have same VPN concept. Okay, but I don't have tunnel. Same, I have a routing table here. Same, I have a routing table. Just this is interface Z0. Note it down. Z0. This is considered loopback or whatever. Let's consider G1, and this is again G1. So I have directly connected 11.1.1.0/24. Which interface? 0. Second is 1.1.1.0/24. Which interface? Z1. So here directly again, I have 15.1.1.0/24 interface Z0 and again 2.2.2.0/Z1. So I'll configure here one default route.
Excuse me, sir.
Yes, please.
/24, then G1, sir.
Okay, no problem. That's fine. Okay, thank you. I'll correct it. Okay. So this is 11.2. Let's consider this is my 11.2 here. And this is about 15. So this is 24 and then 3. This is about then what is that? 15 dot. Okay. Tomorrow we have class. Okay. I was saying that you might that is actually next week, not on this Thursday. I thought it's on this Thursday. I think I have not shared Drive, right? Drive. I have shared. Okay.
No, sir.
No. Okay. Might be your. I have missed your email ID. No problem. I'll share it today again. I'll share one WhatsApp group link. Okay. So already I think 200 students are there. So join the same. Okay. No extra messages related to the technical only. Okay. Now this is clear. Now see. Let's consider, I just want to ping because overall what I just want whenever I'll just exchange or the like establish any kind of communication between 1.1 and 2.2 LAN A and LAN B, that should happen via tunnel here. So but I'm not using routes today. So I'm going to be use ACL concept here, which is known as policy-based VPN. Now, so see, let's ping to 2.2.2.2 as a source of 1.1.1.1 here. So what is the destination? 2.2. It would look into the routing table. Do I have a routes for the 2? Let me check it out. I have default route. Means I can go anywhere. Who's the next stop? 11.2. Do I have a reachability? How to reach to the 11.2? Let me again look into this. 11 network is there. Which interface? Z0 here. So it would take the exit from here. It would reach to the destination. During the reply, what would be the destination IP? 1.1.1.1. Do I have any reachability? I do have what? Default route. How? 15.2. Like how to reach now which exit interface? 15 network, Z, 0 interface. Clear? So now I have configured in a VPN. The concept is Amit, then how VPN is going to be work out. Okay, because traffic is what? We are not going to be play or we are not going to be do any kind of changes into the routing table because this is not a route-based VPN. So what we have to do it in the VPN configuration itself. Okay, there will be one ACL. One ACL will be there. Usually, why do we use ACL? Usually, why we use the ACL? To allow or to
filter the traffic.
log. Okay, or in case or in short, like to filter the traffic here. Okay, so today again we are going to be use same concept. Okay, but today I'm going to be use ACL as a to identify interesting traffic. To identify interesting traffic. Interesting traffic means which traffic you want to exchange via tunnel. Okay, so I want to exchange the traffic for what? 1.1.1 and between 2.2. Just consider one more thing along with this. Okay, on the same route, like behind this, I have here 3.3.3.3, and this is I have 4.4. Clear? So this is about Z2. Consider J2, and I have again. So two LANs we have, right? So this is LAN A and LAN B, this is LAN C and LAN D here. So what is the requirement? Okay, first note it down. All done. So what is the requirement? The requirement is when I'll exchange the data between LAN A and LAN B, means between 1.1 and between 2.2, then it should use what? Tunnel, or it should transfer via tunnel here. But whenever we would exchange the data between 3 and 4, that should go via this one. So previously we were playing with the routing. Okay, so this time we don't have to play with the routing because we have same default route on the both the sides. So this time in the VPN configuration, we have to use one ACL on this interface. ACL on the this interface, and in this ACL we have to define if my source IP is 1.1.1.0/24, if my destination IP is 2.2.2.0/24. Protocol also you can define it. If you would define IP, so all kind of traffic. If you would define TCP, then specific TCP traffic. So let's consider I'll use what? IP here. So I have to define this ACL inside the VPN configuration. And same on this side, I have to define again one more ACL inside the, but this time who would be the source? 2.2.2, and who would be the destination? 1.1.1.1. Okay, as you know, ACL or VPNs. Okay, because in the upcoming classes, when we will configure the VPN, in the VPN we have a concept about crypto map. That is one of interface-based concept. What is that? Interface-based concept. And inside the mapping, inside the crypto map, we have to call our, if you have more than one AC, or you can say AC. Clear? And this crypto map concept would work where it would work on the interface. Clear? As a network admin, I know okay, I have to configure in a VPN between this interface and between this interface. So during the configuration, how many interfaces do I have? Z0, 1, 2. So I have to call it on which interface? Z0, and here again Z0. The question is, okay, Amit, what if I'll configure it again here? Let's consider instead of this one, if I'm using here, what happened? So this is your human error. This is a configuration error. There's no solution for that. Okay. So you have to make sure कि first of all, you have to understand where I'm using the VPN. So I'm going to be use the VPN between this and this here. First condition is that reachability must be there. We have to check that the ping is happening or not. And after that, we have to start the VPN configuration. All clear? Okay. So do one thing, note down about CryptoMap. Online students who has not received Drive access, kindly share your name, email ID, and mobile number.
Yesterday already we shared, sir, but I didn't receive.
No problem. You just share it again.
Okay.
Might be I have missed it or something. Okay. So who has not received it, so just kindly share your email IDs and name in the chat box. Physical students, I hope everybody has received. Right? Fine. Now tell me, as per your interest, this is your interest. After this ACL, okay, now let me finish now. It will take 5 minutes. After that, I'll ask you. Now see, this is what Z0 and this is again Z0 here. It's fine. So I have called this interface on this. Now see what happened. When I'll generate a path data here, ping comes under your IP terms, correct? Instead of let's consider IP, if you are using TCP, then ping doesn't come your in that, because in this what telnet SSH concept would comes HTTP, HTTPS and all. Okay, because ping is not a TCP, that is about ICMP. But if I'm using an IP, so IP means one is the open box, which is for IP means all protocol. Okay. Now, if I'm doing ping, who's the source? Sorry, who's the source? 11.1.1. Destination is 2.2. So let's consider router will check it in routing table. Do I have any route for the 2? As you know, I have already configured default route. Who's the next hop? 11.2. Let me check it out. How to, which interface is the mandatory for that? Like, or you can say from which interface I have to take the exit. So 11.network, which interface? Z0 interface. So now let me take the exit here. So data would come here. So first of all, this checking, okay, when the routers would look into the routing table. Let's consider the router is looking into the routing table. So that process would happen in your control plane. Okay. After that, data would reach to the this interface here. From taking the exit from here, before taking the exit, okay, as you know, on the interfaces, we have always two kind of policies. One, we have inbound policy, and second, we have outbound policy. Inbound policies for incoming traffic and outbound policies for the outgoing. So this traffic is taking exit from here, so it would check its outbound policy. So in outbound policy, we have already configured what? CryptoMap. So in the CryptoMap, then router will check it. Here I have one ACL. So which is the ACL here? This is the ACL. So as per this ACL, what is the source IP? 1. What is the destination IP? 2. It's matching with the traffic? Yes. And then it would transfer or it would send your data via VPN. Color? Let's consider you are doing a ping to 4.4.4 and source is still your 1.1.1.1. Again, it would check into this. Again, it would come say we have default route, can go anywhere. So then this router will check it CryptoMap and CryptoMap would check with the this one. The source IP 1.1, that's fine. But the second is destination. Is this 2.222? But what is my destination? 4.4. Is there any matching into this? No. So then it's not going to be used VPN. Then it's not a drop or okay. So now what happened? It would send the data via. Clear or not? Okay, because we have not configured access list for which traffic? For the this traffic. Clear? In case if your destination IP is 2.2.2.2 and source IP is instead of 1, 3.3.3 here. So again, it won't happen. The reason because destination IP with this is matching, but what about the source? No. And in case if you're using here TCP and your data is about, you are using ping, but in IP instead of IP, you have defined what? TCP. So this is a ping. So then source IP, destination IP is matching, but what is not matching? Protocol is not matching. Or might be you are using a 23 here, which is telnet. But here in this one, TCP, you have mentioned equals to 80, which is about which traffic? HTTP. So this is telnet and this is HTTP. Again, no match. Okay, so then it won't work. Okay, so based on the ACL, now routers would decide if data would pass through the tunnel or the VPN, or data would pass through the ISP. Clear or not? So this concept is known as policy-based VPN. Okay. So whole VPN concept is dependent on these two things. The one is a route-based VPN. Okay, and then we have policy-based. These are the two categories. Okay, so there's a two possibility in the VPNs whenever we will configure. Might be we are using routing table, or another option is we are using ACLs. That's it. Okay, so based on this concept only, your devices would decide. Any doubt, any questions in this? Online plus offline. Online guess first. Any doubt, any questions? Anyone?
Sir, like in policy-based VPN, we only use ACL or any other like policies?
No, only ACL concept we have.
Okay.
Okay.
Sir, both
Yeah.
concept we can use in single tunnel, sir? Like
No, one concept only.
okay. Okay, sir.
Okay. All clear? Now, types of VPN in the context of deployment. In the context of deployment, then you can say the types of VPN in the term of deployment. Okay. We have two types here. One is site-to-site VPN, and second is remote VPN. Site-to-site VPN means on both the sides. Okay. So what both the sides, on both sides, the IPs, okay, should be static. Static, and it's always public. VPN is always between the public. It can be between the private also, but there is another VPN concept we have. But right now in the starting, you have to make sure one thing: the VPN is always between the public IPs. But site-to-site VPN is always between the static. But in the remote VPN, the first condition is what? Public IP. Okay. And second is there is a possibility one side can have static and another side would have dynamic. Dynamic means switches keep on changing. Note it down. All clear? So let's talk about first site-to-site VPN. Okay. So see, This is side-to-side VPN. Side-to-side VPN means this interface, this IP and this IPs are, if you're using static, let's consider this is your Cisco's campus Bangalore, Cisco Bangalore office. This is, let's consider Cisco Delhi office. Now Cisco's in the Bangalore, it's in Marathali, Cisna Park. Okay, it's been I think 14-15 years at the same location. They are not keep on changing. It's not keep on changing. So whatever the IPs they are using into their edge routers and all, okay, outside one, that is static. That is not like in a day 10 times they are changing it, or every week they are changing after 6 months or after 1 month. But that 1 month or 6 months, okay, that is the static timer. That is the static timer. So that concept of when between both the sides you are using a static IP, that concept is known as side-to-side VPN here. For example, because in the configuration of the VPN here, okay, because see, when we will configure VPN here, in the VPN almost 24 up minimum 20 commands will be there. How many commands? 20. And in that we have to define a concept about peer. What is that? A command in between peer. Peer means another end. Who's my another end from this device? 15.1. And same here, we have to define one peer. And who's my peer? 11.1. So this command is the part of that 20 commands, sir. So on the daily basis or on the hourly basis, we cannot change it. One small change in the VPN, there would be the downtime. Means what kind of changes? Let's consider at morning AM, its IP is 11.1. After some time, it would be 11.5. After 15 minutes, it's not possible again and again I'll change a peer here. And in case if you want to change it, first of all, you have to hire one engineer for that. One specific guy should be there, right? Who would be continuously, who can just what? Who can keep the eyes on this IP address. Okay, what is the IP? And then again and again he has to change into this one. Okay, now instead of 11.1, 11.6, or might be next is 19.1 or 19.5, whatever. Okay, so this practice is not possible. So side-to-side VPN means when we are using a VPN between two static sites, okay, or between two static public IPs, that concept is known as side-to-side. Networkers of, I think in this building, it's been 13 years now. Okay, we are still in the same building. We are still same public IP. Okay, which we have bought it in like 13 years back. I think in between we have changed once. Okay, but still two public IPs only we have used till now. Okay, we have one branch in Delhi, still same public IP we have in Spain last 5-6 years. Okay, so in case if we have to use a VPN, so we have static IP. After 1 year, 2 years, if we are changing it, it's fine. That is a one-time change. But again, that should be stable for the next 1 year, 2 years, 6 months at least. It's not in morning I have changed, in an afternoon, again, they are changing what? IP address. Clear? The question is, Amit, okay, this is the side-to-side VPN. Then what is the option about the remote VPN here? Remote VPN means one IP would be static and another IP would be keep on changing. I'm using LinkedIn. Okay. I have opened the LinkedIn page. Do you know what is a LinkedIn IP? No, because who is helping us into this? DNS. Okay. But for example, right now you just consider DNS IP is 15.1. Even see, the thing is, right now, this is my PC. It's me. I'm connected with internet. After that, there is a Google DNS, and then there is a what? LinkedIn. This is a Google DNS. This is connected here. This is into this, and this is up to here. Now, I am just consider, for example, my public IP is 18.1 because I have to find out what is my public IP. If I check it out, here you can check it out, your public IP. This is my public IP, what I'm using here. Okay, consider this is Google 8.8.8. So this is what? Google DNS. And this is what, let's consider LinkedIn. Whatever is their IP, they're using 18.1, 20.1, 17.1. That is always what? Here, LinkedIn.com is about 19 or 99.1.1.1, or might be whatever they keep that. Okay, they also not keep on changing. Okay, because if LinkedIn is doing any changes in the IP address, they have to request to whom? They have to send in a request to the Google DRS to update their IP. So these practices are not on the daily basis. Correct. This is not on the daily basis. Okay, every day they are changing the IP address and all. That doesn't make any sense also. So let's consider, for example, I'm using here 99.1.1.1. Okay. Right now I'm in office. My IP is what? 49. This. After some time, after 2 hours or after 6 hours, I'll go to my home and I'll be connected with, let's consider right now, you are connected. I'm right now here, I'm connected with the Airtel. At my home, I have Act. Okay. So then I'll be connected with the Act. From there, I'll get the another public IP. Let's consider that is something. Okay. But the LinkedIn IP is still same. Let's not keep on changing. This is what? Same here. Okay. Whenever we are using HTTP, the traffic is secure. Is this secure HTTP? No. But when I'll add S in front of this, now this is secure. Because of what? SSL. So whenever you are using HTTPS, by default, we are using VPN. Technically, might be, I'm not sure you know or not. Okay. But technically, if I'll talk about whenever we are using HTTPS, so we are using VPN. That VPN is known as SSL VPN, or that VPN is also known as remote VPN. That VPN is also known as browser based VPN. That is what? Browser based VPN. That VPN is also known as web based VPN. This VPN is also known as clientless VPN. Note it down. Whenever, and in HTTPS, whatever, if I'm using HTTPS networkershome.com, I'm using HTTPS cisco.com, I'm using if HTTPS Facebook, Instagram, WhatsApp, whatever, all are secure. HTTPS secure because by default we are using a VPN into this. Okay, and which VPN? This VPN. These are the VPNs. So one side IP is static, and on the another side IPs are keep on changing. Let's consider after that you're just going to your friend house, okay, into different area. So he has again different public IP. After that, you are sitting in the cafe, different public IP. You're using your mobile phone, different public IPs. Okay, so this one side IP is static, but another side the IP is what? Dynamic. So that VPN concept is known as remote based VPN. This is one of the scenario. On the daily basis, we use it. HTTPS, ICICIbank.com, or anything, wherever you are using HTTPS. So this is protocol is same, HTTP, but S means in front of this, we are adding what? SSL. What we are adding? SSL. And this is the VPN concept. Okay. Now, let's consider in the real corporate how we work. Let's consider this is Cisco's device, Cisco's router or whatever. So Cisco is what saying? Cisco is hosting one server inside their network, and they are just providing the access to the outside users. let's consider this is related with some documents or videos related to the CCI, okay, lab exam or whatever. So Cisco is all like connected over the internet. They are connected with this. So let's consider here IP is about 18.2. And here inside that they're using the public IP also. Let's consider 16. or 15.1. Now, this says I'm a user. I want to access that particular server. Okay. So what happened? The Cisco would ask you how to use what? HTTPS. HTTPS means one of the VPN here. This is the category of what? Remote VPN. If I'll to earlier, which category was there? Site to site VPN. In site to site VPN, most of time we have to use IPsec protocol. Which protocol? IPsec. And in remote VPN, we have to use SSL protocol. But additionally, can I use a IPsec here? We can use IPsec also, but that is the very rare scenarios. Okay, 99.99 if you would ask me. Okay, so we use which concept? SSL protocol. By default, whenever you are browsing it from your browsers and all, so by default in the browsers, we have which protocol always? SSL. When I'm using a browser-based concept, so which is the concept here always? SSL. Okay. Physical students, how many of you are working right now? No one is working. Any experience? Anyone? No. I hope you have seen your like your brother or cousins and all who's working professional during the COVID. They used to do what? Work from home. At this moment also there is a lot of work from home concept is going on, but that time 100% concept was what? Work from home. So they used to work from home, right? No. At that time only we will discuss, not now. Okay, when I'll start the GRE, then only we'll talk about GRE. So now the concept is, let's consider this is your brother and he's working from home. Right now he's at home, it's fine. His public IP is about, for example, his public IP is 16.1.1.1. Next time his public IP is something, he moved to his like friend house which is nearby 19.1. They moved to some other place 16.2.5. whatever, this is IP. IPs keep on changing, but his office public IP, which is here, that is fixed. That is what? Fixed here. See, if I'll talk about a remote-based VPN, so remote-based VPN is categorized into two different categories here, or you can say it has the two types. One is a browser-based VPN, okay, or this concept is known as clientless VPN overall, and this is known as client-based VPN. The remote VPN has a two type. One is clientless and second is client-based here. Clientless and client-based. If I'll talk about clientless VPN is known as browser-based, web-based, okay, and browser-based and web-based. And along with this, proxy-based VPN. Okay, and this is the category of what? This is the category of your remote VPN. Okay, so this is also another client. This is the client. So four names we have: clientless, browser-based, web-based, and proxy-based VPN. Second, we have client-based VPN. Okay, so the client-based VPN in the term of Cisco, we call it again AnyConnect VPN. Which VPN here? AnyConnect. AnyConnect is what? AnyConnect is kind of one of the, what is AnyConnect actually? AnyConnect is kind of a software, or you can say package. This is software or a package which you have to install on your PC. This is in the context of Cisco I'm talking about. In the context of Palo Alto, it has a different name. In the Checkpoint, FortiGate, different vendors, different softwares. So in the term of Cisco's, what its name? Its name is AnyConnect. So let's consider this is your brother, okay, and he is working in Cisco itself. Let's consider this is the Cisco's one. So he's working in company and he has to connect himself with the Cisco's network here because he's working on this server. He need to do some changes or whatever. So how that would be possible? So when you are using clientless VPN means when you are using a browser-based VPN. So do you think with the help of browser, you can do any telnet, you can do any configuration, CLI configuration on your browser? No, because for that we need what? PuTTY, and for that I need SSH or telnet. SSH is secure and telnet is not secure. So means when I'm talking about Facebook, you can access Facebook, but you cannot make any changes on the Facebook there. You can access Instagram, you can access LinkedIn, but technically we cannot make any changes on their server because we have access of that server, but that access is very limited. What is that? Limited access here. But let's consider you are a person and who's working in LinkedIn or Instagram, and you have to make some changes on that particular server with the help of command line, CLI. Do you think the browsers is going to help you? No. We need a software like PuTTY, Telnet, SSH and all. So if you want a full access of the server, instead of the limited access, you want the full access of the server. So you need this kind of VPN, which is known as client-based VPN. So this is the reason this VPN is also known as full access based VPN. This VPN is also known as full access based VPN. So limited access client-based, clientless, that is fine because on the daily basis we use, okay. Okay. So this concept is when you're using this, okay, this concept is, so we have to what? You need a full access here. Instead of I'm not a user, I'm an administrator. I'm not a user, I'm an administrator. I need a full access here. So in that scenario, what is there? The concept is as a user, I have to install AnyConnect over. This is one of the software, okay, and I have to install. Let's consider I'll talk about AnyConnect. This is the software of the package, and once I'll connect it, after that it would ask me with whom you want to configure or you want to connect a VPN here, okay. So I'm saying I'm going to be connected with the 18. It would ask me username. Let's consider admin. The password is again admin. So after that, it would be connected with what? VPN connected. Okay. Okay. So here IPs are keep on changing, but I'm not using any SSL here. I'm not using any, and this is not a, sorry, I'm not using any browser because this is browser-based VPN with limited access. Okay. But I want a full access. Side-to-side VPN would always provide you the full access. Okay. But that is for the static concept. But here, one side we have dynamic IP. Clear? So this VPN is known as full access VPN, full access based VPN, client based VPN, AnyConnect based VPN, software or packages based VPN. So first thing you have to understand what is the meaning of remote VPN here. What is the meaning of remote VPN? So in the remote VPN, we have two categories. Okay. One, we have clientless VPN, and second, we have client based. Clientless is browser based. On the daily basis we use, but with limited access. And second is client based. So you can check with your, if I can see the physical students, you don't have an experience in the corporate, but you can check with friends or your cousins and all who is already working in the same domain. So on the daily basis in the morning, whenever they are connecting or when they are trying to log in into their portal, okay, if they are working, if they are doing work from home, so first they have to connect with the VPN. Okay, after that only they would be able to open their portal pages and they would be able to log in, because your portal page is what would open from here. And let's consider if you're not connected with VPN, so here there won't be any connectivity. Okay, so that's the reason first you have to connect yourself with the VPN, and after that only you would be able to access the login page or the portal from this particular site. Okay, IPs keep on changing. That's fine. We don't worry about that, because in this configuration, because this is the one of the VPN here. Okay, so this VPN here, I'm not defining any peer here, because in the term of the peer, okay, I'm not defining that. Dynamically, they would learn who's my peer. So dynamically, that is keep on changing. So let's consider right now you are connected with this and you have shut down your PC. VPN got disconnected. Next time, again, when you open it and you want to again start the same thing, okay, you have to connect with the VPN again. So VPN connection in the starting, when you would try to establish a VPN, that process can take 10 seconds, 20 seconds, and 30 seconds. Okay, but in side-to-side VPN, I don't want that. Okay, I just want full VPN concepts here without any kind of downtime. Let's consider right now I'm working, I have power of my laptop. Next time, again, when I'll on it, so I'm saying it can take 10 seconds, 20 seconds, 30 seconds, based what kind of client you're using it, what is their throughput and how it's working. So that 10 second, 20 second, and 30 second is your down. What is that? So that process takes time. Let's consider what I'm doing. Let's consider I'll just open any something. Let's consider Netflix. It's taking time. I might be 2 seconds, 5 seconds. What is that? Downtime on this. Okay. So on the side to side, we don't have that kind of concept. Okay, because there the data is keep on traveling. You can so keep on exchange. Is that clear? Okay. So this is the concept about your site to site and then remote based VPN. Okay. So till now we have discussed about, like in the term of VPN categories, we have discussed here first. One is route based VPN. Second is policy based VPN. Next concept in the term of the deployment. In the term of the deployment here, it has two types. One is site to site, and second we have remote. And the remote has again two categories. It's two types. One is client-less, and second is client-based. Is that clear or not? Any doubt, any questions into this? I hope all clear. Try to practice all this thing, because in an interview, the first question they would ask from here: what's the difference between remote VPN and site-to-site VPN? What is the difference between clientless and client-based VPN? It's easy, but once you would start explaining, then they would ask you so many questions in between that. Okay, so try to practice on a page, like on your whatever notebooks you have. Okay, what is route-based VPN? They try to explain it yourself. Okay, then only it would be possible for you to explain these things in the interviews. Clear? Okay. Now, after this, we have discussed we have a VPN, we have a tunnel and all, right? So this is what we discuss as about secure. Question is now how? Answer is with the help of cryptographic methods. What is that? Cryptographic methods. Note it down. So now the topic name is what? Cryptographic methods. So this is the last theoretical concept here. After this, we have to start with the practical. Okay, so what are the cryptographic methods we have? There's a lot of cryptographic methods, but as per your syllabus and exam and all. So first we would discuss about encryption. Actually, encryption concept is known as confidentiality. What is known as confidentiality here? Then we have hashing. Okay, this concept is known as, this is the hashing. Okay, this concept is known as integrity as well. What is that? Integrity. And next we have authentication. Okay, so you can consider it as a CIA: confidentiality, integrity, and authentication. How to achieve confidentiality? With the help of encryption. Okay, how to achieve integrity? With the help of hashing. And how to achieve authentication? With the help of authentication methods. Okay, so in interview, instead of asking encryption and hashing, because in the upcoming classes, I'll use these two terms again and again: encryption, hashing. But might be in interview, they won't ask you directly about encryption or hashing. They would ask you how to achieve confidentiality and integrity into your network, or what is the meaning of integrity in your network. So means they are indirectly asking about hashing. Okay, so note it down. This is very carefully. Encryption means about confidentiality, or you can say how to achieve a confidentiality into your network with the help of encryption here, and how to achieve integrity with the help of hashing. Authentication word will remain same. Encryption, so you know, right? I hope, right? So encryption concept is means confidentiality. So you can try to cram it like a CIA. Okay. Now, next we have here the concept about, if I'll talk about encryption, how to, what algorithms we are using it. So there is some basic algorithms, like one is dash, 3 dash, and then we have ASO. Then hashing, or means hashing how? With the help of MD5 and SHA. SHA has a different variations and all. Okay, 256, 512 and all. And then we have authentication with the help of PSK, pre-shared, and then we have PKI, public key infrastructure. So this is public key infrastructure, means this is the concept about digital certificate. Concept about what? Digital certificate. I hope you heard about certificate concept, right? So that comes under. So I'll try to finish at least 2 concepts today. Okay, at least 2. And if I'll try for all 3. Now see, all done up to here. Now just listen for the next half an hour. Okay, and between, if you want to make any note, just let me know. Okay, but don't try to make a note along with this. If I'm explaining, so just focus on this. Now, encryption here. Encryption what? I have a plain text. What is that? Plain text here. Case, could you tell me what is this? It's my name, Amit Tawar. But if you would ask, if I'll ask you, what is this? No, this is known as plain text, and this is known as encrypted data. What is that? Encrypted data, or just note it down. One is encrypted data, and ciphertext. What is that? Ciphertext. So what is encryption? Encryption is kind of one algorithm, or it's kind of one method we have which would convert our plain text into what? Encrypted format here. Encrypted format or encrypted data, or you can say into cipher text. Okay, if you would read books in the future about VPN, so instead of encrypted data or format, they always use technical word what is that? Cipher text here. So cipher text is encrypted data. Okay, this is site A. Note, this is site A. This is site B here. Connected over ISP. Now, this is site A. This is site B. Connected over the internet. Okay, this is site A, this is site B. Its public IP is 11.1 and this is about 12.1. Let's consider this is ICICI Bank here. Okay, Bangalore branch, and this is ICICI Bank again with the Delhi branch. Right now, no VPN. Right now, no VPN here. There is some customer data here. This is the customer details. Okay, the customer details means like customer information. Okay, they have some customer details, and let's consider this is the customer detail. Into that customer detail, what will be there? It's about the customer name. Okay, and customer other details like mobile number and all whatever. Which is a very crucial data, because as a ICICI Bank, I don't want to share my customer details with any other bank or whatever. Okay, so what is that? This is one of my customer detail. Okay, and the list of the customer details I have to share from Bangalore branch to the Delhi one. I have to exchange with that. Obviously, it's not possible that I'll send one of my employee that you just travel to Delhi. This is their pen drive, take it, and this is the list of the 100 employees or like employees or whatever the customers, and just what? Give it to Delhi. Time taking process, expensive. Delhi branch is asking we need within an hour. Okay, Bangalore to Delhi, traveling time is minimum 3 hours. This is the traveling time. Okay, okay. After that, then again 3-4 hours is here extra, and then overall it would take 12 hours. Okay, so that within a 1 hour it's not possible. So you going to be take the help of what? Internet. This is about what? ISP. But ISP we know that is not secure. Okay, so there is so many hackers and attackers. They are just also connected with the internet, and they're just waiting. Once this site and this site would exchange the data, in between we will sniff the data over. They have some own methods. They have so many attacks and tools and all whatever. Okay, because they are also expert into their domain. Okay, so they're just waiting. You just started. After that, we will take care about, because once your data would comes, like once your data would be into flight. This is known as data in flight. Okay, once your data would be in the flight, then we will take care about that. Clear or not? Okay, so let's consider I'm sending in a data, and this is consider I have sent it. Right now, the concept I'm not using a VPN. I'm not using VPN. No VPN, no cryptographic methods, no algorithm, nothing. Right now, nothing. So I'm sending the data, and somehow they managed it to my data is first. Instead of going directly, this is kind of man in middle attack is there. What is that? Man in middle. Man in middle concept means first data would goes to the third party, and from here the data would goes to the this one. So what happened? My data would comes to this, and this data, as you know, this is into which text here? Plain text here. Okay. So what happened? The data would be, he can easily read the data, he can copy the data, and he can keep into this. And after that, he would send the same data where? To the destination. So what is happening in between? We are sending the data in a plain text, but in between, because of man-in-middle is happened, okay, someone is able to sniff my data. Not secure. So what I'm thinking, the first concept here, key I'll use here encryption concept, encryption method or encryption algorithms there. As per that, first I'll change its format. I'll change its format of my data here. So for that, I have different algorithms. Algorithms like one is dash, 3 dash, and we have AES. There is a one digit. This is one A. In the what is dash is saying ki A means this. As per A, as per dash, what is the symbol they are using for A? This one exclamation. What is this? At, and they are using what? Dollar. In A, what they are using it? They are not using directly A. They are using what? They sign, sir. For M, what they are using now? For them, are using dollar. This is next is this, and this is for. For I, it's using, and it's using star, and it's using. And for T, it's using at. Let's consider it's they are using dollar. Clear? So see, first of all, if you are going to be use an encryption algorithm, okay, let's consider this. Okay, this is my this is the information only one name, which is Amit here. So this is my data. So instead of sending in a plain text, I want to send into which format? Encrypted format. It would convert into encrypted format. I'm saying ki on a site A, first of all, on site A, what happened? Encryption. What? It would encrypt the data, and on the another side, when the data would reach, what is required? Decryption. Decryption, which would convert encrypted data into the actual. So what happened? Let's consider Amit, and I'm using here algorithm, for example, dash. Okay, and this is something like this, for example. Okay, this data now I'm sending over the ISP. Man-in-middle attack is there. This data would come to this one. Okay, so what happened? This guy, what he will do? He will make a copy of the data with itself and keep with him, and another one actual data would send it to this. Here we are using what? Dash. Here also I'm using what? So it's mandatory. Okay, you have to use again dash only. This is the must. Okay, for encryption, if you are using dash, for decryption also you have to use dash here. Amit, why? The reason is, let's consider I'm using data is Amit. If I'm using dash here, so it would be convert my data into which one? Into this concept. This would be my data. As Amit, this is my Amit. And I'm using which one? I'm using here dash. So as per dash, this is my ciphertext. Correct? On the another side, let's consider if I'm using AES for the decryption here. So as per decryption, it would try to decrypt it. So first word is what? This one, exclamation. But Ash is saying, AES would say, ki I don't have any this sign. I don't aware about this, what exactly this is. Second is dollar. Do I have a dollar? Yes. So second alphabet is what? First, I don't know. Second is what? A. Third is AND operation. Is there AND? Yes, that is what? T. And next is what again? At. I do not have. Do you think this is a proper data? No. Means dash is encrypted. So here we have encrypted with the help of dash. But on the another side, they are using AES. So, and what is happening? They are not able to decrypt. So the first condition in the encryption is on the both the sides, encryption's algorithm must be same. Kindly note it. The first condition of the encryption is, okay, that encryption algorithm must be same. This is one of the reason. Okay. One guy is kind of like speaking in Spanish. Again, another guy is talking in French. Okay. The French, he doesn't know like Spanish, and this another guy doesn't know French. So this is what kind of encrypted for them. Okay. So they are not able to communicate with each other. So on the both the sides, common language or common methods must be there. All clear? Now, so this is the concept is clear. First, what is encryption? I hope this is clear, which would convert your simple text into the ciphertext here. Second thing, that must be same on the both the sides here, right? So this is, let's consider, I'm using same dash algorithm. So successfully, this is dash here, and once this data would reach here, would be able to convert into as a what? So this is mine. Okay, so see, this is dash. First of all, Amit converted into ciphertext with the help of what? Dash. This is again encrypted data reached. Now decryption would happen with the help of the which algorithm? Dash. The reason that must be same, and now we got what? Got the data here. The question is, ki Amit, okay. Now as a student, I'm asking, up to here it's clear or not? This fundamental is clear, and I hope this is clear. Anyone, any doubt? The thing is, okay, Amit, we are just getting happy ke reason ki we have converted this text, the plain text into the cipher one. We have sent over the ISP. This guy is also having the one copy of my encrypted data or not. And here we have this data reached, and we have decrypt, and this is the data. So why you are just happy here? The reason is because this side we are using dash and this side we are using dash. Let's consider this data is very crucial, very important for the hacker. So he is also aware about the dash algorithm or not? Might be right now he is not aware about that. You are using dash. Might be he would first try to decrypt with the help of AES, then he would use 3 dash, and then he would use dash. So in the end, he also would get the result or not. Might be it would take time for him, no problem. Okay, he would try with a different method, but finally in the end he also would be able to decrypt or not. Correct? It's taking time. Earlier he was getting the data in the plain text, but now it's taking time to decrypt the data. But it doesn't mean that dash is one of the proprietary. This is not no one's proprietary. These are the open standard algorithms here. Open standard algorithm means if this is the ICICI Bank, that doesn't mean that other banks or other organizations, they cannot use dash. No, this is the open standard. Anyone can use it. Correct? So then what is the how it's now secure? Yes, I agree. Instead of sending the data in the clear text, we are exchanging the data in the ciphertext here. Earlier, he was getting the data directly, but now it's taking 10 minutes more for him to decrypt the data. One extra process only we have added. Then how you can say that this is secure? Is that clear or not? This is one of the problem here. The problem is, okay, you are happy, but you cannot be happy for the long. The reason is because after 10 minutes, he is also able to decrypt the data. Clear? So how you can say that this encryption concept is secure over the ISP? And then what is the use of this? This problem is clear or not? Solution I'll give you now, but now just tell me the problem is clear or not? Online students.
Yes, sir.
What about other?
Yes, sir.
So guys, I hope it's clear. Okay. So now, one first simple example. I hope everyone knows this. right? Okay. Now, one is your mom is making tea. Different taste. You are making tea. A different taste for that. Okay. Your siblings, your sister, brother, he or she is making a tea. Different taste. Might be out of three guys, okay, you are very good into tea. It happened at family always there is a one member he makes good and better tea, okay, with elaichi, adrak and all, right, with ginger and all. So see, but the tea powder, the sugar, milk, the water, the gas, okay, after that the elaichi, the ginger, everyone is using, right? That's common, but the taste is what? Different. Okay, so means might be first, like now your mom is what is doing, she's putting all the everything at the same time. Okay, and after that she put it on the stove and then it would take 15-20 minutes. Might be in the starting, in the you are just taking time with the water and the ginger and only. Okay, so means concept is like we have same, everybody has this material, but the taste of the tea is what? Totally different. When you would go out, okay, at any local tea shops, which is on the corner, every corner we have tea shops, the taste of their tea would be totally different. You once would go to the chai point, the taste of the chai at chai tea point, okay, their taste is totally different. Go to the this one, uh, so many other like tea shops and all. So taste of everywhere is different or not, right? So the same concept is here. Everybody knows dash. Okay, even as a source, as a destination, and in between as a hacker. We also knows dash here, but this is the my data, Amit, which we have converted. Okay, so it means everybody would be able to convert into the plain text. Answer is no. In this world, only two guys can decrypt the data. One is the sender, and one is receiver. Not in between. Yes, they knows dash, but still they won't be able to take it. Okay, except these two guys in this world, no one can decrypt that encrypted data. Okay, but here we have discussed, this is the possibility we have discussed, right? This is possibility or not, this is one of the problem, right? As a fresher you are thinking, then how? The answer is that's not possible. This encryption, this side, this is not possible. The reason is they are not aware about the recipe. The recipe means they knows the method, but they don't know, he doesn't know how to do it. Because the reason is when this encryption would happen, when this, let's consider how actually encryption happened now. Okay, the thing is, if I talk about encryption, for encryption we have always concept about the keys. What is that? Keys. One is public key and second is private key. Public key we can share, okay, and the private key is what we cannot share. Okay, clear or not? Note it down, because now which concept comes in the role here? Keys. One concept we have public key and second we have private key here. Usually, if we are talk about encryption, that always would happen with the help of public key. With the help of what? Public key. And second, the private key is always what? Also, you can say the decryption would happen with the help of always private. This is the concept. Encryption always with what? Public, and decryption always with the private. Okay. Public keys are shareable, which we can share. Private keys we cannot share. Today is 4th of October. Okay. In the last class of VPN, I'll change this statement. Okay. In the last class of the VPN, we will discuss yes, private keys also we can share and public keys. So the concept is this is I'm saying here we cannot share, but in the last class of VPN, I'll change the statement because of one scenario, and there I'll ask you, yes, private keys also we can share, but not now. That would be in the last step. Right now, the encryption is happening with the help of what? Public, and decryption with the private. In future, we would discuss like encryption with which keys? Private. Okay, or else now only you can just down. This is the normal concept. Special scenarios you can mention it. Yes, encryption can be possible with the help of what? Which key? Private. And decryption with the help of the public. And this scenario is known as digital signature. Which concept? Digital signature. So where encryption would happen with the help of private key. So the normal encryption what? In the normal concept, encryption would happen with what? Public. Okay. But in future, when we would use digital signature in SSL VPN, so that time encryption would happen with the help of private key. Reverse. Okay. Then decryption would happen with public. That is the opposite concept. But that is in term of or in the context of digital signature. So this is one of the special keys. Okay. But right now our focus would be on which concept? Our focus on this concept. Okay. So let's talk about the normal concept. So as I have mentioned, encryption would happen with what? Public, and decryption with the private. In public keys we can share and private keys we cannot share. Site A, site B. Site A and site B here. Connected over the internet. This is one hacker, also connected over the internet. This is you have to mention it as a scenario number 1. We are talking about right now encryption. The concept is how encryption would happen. So this is scenario number 1. We have 2 scenarios there. This is scenario number 1. So site A, this is site B, and this is a hacker. What happened? Let's consider we have decided I'm going to use dash. I'm going to use dash, and he also knows what? Dash. I have, this is my public key. My public key is 1, 2, 3. The private key is, let's consider ABC. Okay. On this side here, the public key is, let's consider 4, 5, 6. And here, let's consider this is CPA. Clear or not? As we discussed, public keys we can share. This site is going to be share its public key with what? Another site. Sending it over the internet, but he will keep one copy of this. Okay. And this is one copy would reach to this one. So this is public key of what? Site A. This is the site A. Agree? On the another side, this is the public key here and can share. It's sending over the internet, and this is again sending over internet here, and this is for the which site? Site B here, and this is site B. So site A is having the public key of what? Site A is having the public key of B, and site B is having the public key of what? A here. Okay, and he is what in sniffing the data, he has the public key of both the sites. Up to here, any doubt, any questions? All clear? Let's start. This is my data. This is the data here. Data need to be encrypted. So its encryption is happening. Let's consider this is the encrypted data. Which algorithm we are using? As we have decided, dash. But for encryption, it would now this device would use the public key of what? Site B. The public key of what? Site B here. Now in this, so this data is what? Encrypted. Yes. So now here I'm using a dash algorithm. Okay. So what is happening here? Okay, this says Amit, we are what? Converted into what? Into the encrypted, sorry, into the ciphertext here with the help of the which algorithm? Dash, but which keys I'm using? 4, 5, 6, which is the public key of what? Site B. Now in this world, only one guy can decrypt this data, and that is only site B with the help of its private key. Are you getting my point? Right now, in this world, only the one guy can decrypt the data. Who has the private key of what? Site B here. So in this scenario, who has the private key of this one? This is what? This concept we are using it, right? So now what I'm doing, I'm sending the data over the internet here. Data is over the internet here. Now he is able to sniff the data, that's fine. But this data would reach now to this one. This hacker is having my data. He knows the dash, but he is what? He doesn't have the private key of what? This one. And this is what? Not shareable. Okay. But this site can decrypt the data. The reason because it knows what? Key, which algorithm we have. We are using dash. I have my private key and now I decrypt the data. So this is decrypted what? With the help of private key of site B. Clear or not? Okay. So because of what it's now secure? Because of keys concept. Because of what? Keys concept. Clear or not? Kindly note it.
Sir,
Yes.
how this private key and public keys are generated?
These are some internal algorithms they have. Okay, so they have some algorithms into that. So with the help of that only they would generate it.
Each one of them are generated both
Yes.
the sites or
Both the-
shared.
Both the sites.
It's not
They
shared
would
or
exchange or they would share their public keys only,
not the private.
not the private key. Because if they would exchange the private key,
That will also be.
exactly, correct.
But I'm not able to understand this private key concept here, sir. Public key, I got it. But private key, how it generates and it generates its own key there, CBA and ABC. How it is happening and how it is
See,
coming.
these are the some algorithms in the devices. We cannot explain and we cannot discuss about those algorithms. They have internal algorithms. Okay. So based on those algorithms, only by default, your devices would generate the public and the private keys there. This is the reason this is what? Secure. Okay. So this is the reason. Okay. We cannot generate these keys here. We can generate, we can share it again. Okay. In case if you want to generate, I'm not sure, have you heard about this command or not? Crypto key generate, RSA label and all. So these are the what? Intentionally we are generating the keys there. Okay. So, but there is other algorithms there. Okay. In the BIOS and all. So with the help of that, they would exchange, or they would, you can say, generate these keys here. Okay. So this is their internal process. Generation of the keys here. How to generate the keys. Okay. So this is public and private concept here.
Amit,
Yes, please.
SSS uses asymmetric, right, which is RSA algorithm.
Hmm.
So whenever I try to take any remote access, so I will be using private or a public key.
That time for decryption, decryption, you are using digital signature concepts there, the reverse one in SSL.
So this digital concept is for websites, right?
See, right now, I know you have so many questions, but I have to go in a sequence only. Okay,
Fine, sir, fine.
so it would take time. Now, right now, you know some points, some other points you don't know. So it's not possible for me to explain each and every point at this moment here. Okay, because right now, just now I have started it. So it would take time for me because it's a sequence. So at least let me finish for 10 days. Then only you would be able to, okay, how exactly things happen. Okay.
Okay, sir.
That's the reason. Because till now we haven't discussed about anything SSL. Okay. So this is one of the scenario where we exchange what? Public keys. We exchange what? Public keys here. Okay. So this is we are using private keys for decryption the data. So this is the reason this is the secure. The second scenario we have in this, see, the main thing is what? Actually, what do you think? Do you think he only dash this encryption method which we are using, the dash or 3-dash? This is because of this is only we are able to secure it? No. These are the methods everyone knows. But because of what we are secure here? Because of the keys. Because of what? Because of keys. This is secure. Okay. One more securest method we have, okay, which is the part of your exam. That is scenario number 2. Scenario 2 here. The concept about Diffie-Hellman. What is that? Diffie-Hellman. So this is not a algorithm. This is not a encryption or hashing. This is the concept about what? This is the concept about key exchange. This is what? Key exchange. Because key exchange is also one of the biggest tasks here. Okay. So in our IPsec VPN, as per the syllabus, we have to talk about the which method? Diffie-Hellman. What exactly the Diffie-Hellman is. So see, let's consider we are using a site A or a site B here. Okay. In site A, site B, we are going to be exchanging the data, which is into which format? Into the encrypted format. Okay, so I have decided that I'm going to be use here dash, and here also I'm going to be use dash. In future, like hashing, we will talk about. Let's consider I'll use MD5 here, and it's about MD5. So when we will configure any VPN between two sites, it's an site to site or remote, whatever. On the both the sides, first of all, we would negotiate which kind of crypto algorithms we are going to be use it. Okay, they first what? First there would be negotiation. Okay, you are also using dash, I'm also using dash. Okay, or now let's consider it would be send one request. Okay, I'm going to be use AES, and this device doesn't support this advanced algorithm, so it would reply ki, no, I do not support, or I don't support what? AES. Let's switch to what? Dash, or let the down one, the 3-dash or dash here. So they would negotiate. So after the negotiation, both that sides, okay, they would decide it ki, okay, these are the algorithms which we have to use it here. In this, on the both the sides, let's consider we have decided what is that? We have dash and MD5, and second we have dash and MD5. Now, for key exchange, we have a method. That method is known as Diffie-Hellman. So we have to decide it ki, okay, I'm going to use Diffie-Hellman group 2. And I'm going to use here Diffie-Hellman group 2. Diffie-Hellman is having some groups, group 2, group 5, group 10, 15. That depends on their key. Okay, let's consider the size. Okay, let's consider once they would generate the keys here. So their size of the keys would be dependent on the group here. Let's consider it's 2. The size of the keys would be small. Let's consider keys is 1, 2, 3, 4, 5. That's it. If you are using its group 10, then key would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like now, this is the size of your key. So the size of the key would be dependent on the what? The size of the Diffie-Hellman group here. So this is Diffie-Hellman group, and we have to exchange the data. We have not data, actually keys. But we have to exchange keys. What would be there now? First of all, we have a key here, concerned about private key. Let's consider its private key is about 1, 2, 3. Or let's consider private key is 10. It has this own private key. Let's consider this is the private key is about 15. Now, three dash concept is clear. For encryption and for decryption, we need keys here. Earlier, we were using single keys, that's fine. So this is the collection of the keys here. And which method I'm using to exchange it? Diffie-Hellman here. So Diffie-Hellman is one of the open standard concept and one of the securest, okay, key exchange method. 99% or 100% only you can say for the key exchange over the internet, we use always Diffie-Hellman. If you are using SSL protocol, or are you using IPsec, VPN, whatever, we always use what? Diffie-Hellman, because this is one of the securest. So the thing is, we have decided this, like this device has generated keys about private and this is private, but they are not going to be exchanged the private keys. After that, both the sides, they would negotiate on single public key. They would negotiate, okay, on a single public key here. Okay, what is the public key I'm going to be using? Let's consider I'll use 20 and you have to also use what public key as a 20. What is that? Public key is what? 20. It would be common. They have to negotiate on the common one. So let's consider on the both the sides we have what? This is 20. After that, on this side, site A, this is, listen it very carefully, guys. Site A would generate one mixture of private and public key. This is a mixture of public and private key. So what is the mixture of 10 and 20? If I'll add 10 and 20, that would become what? 30. So this is the mixture of site A. Mixture of site A, public plus private. Same on the another side. This side would make in a mixture of what? Public and private. So what is that? 15 plus 20 is equal to 35. Okay. My mixtures are ready on the both the sides. Up to here, any doubt, any questions? I hope all clear. This is just it.
You said something of the group.
That is size of the group. What is your age? Let's say my age is 25. More experience? Correct? Our father, the parents, they are like 40 plus. They are having more experience. So same, the size of the keys. Diffie-Hellman, 2 small, 5 more, 10 more. That is the size of the concepts. Okay, so that define the size. Diffie-Hellman group define the size of the keys there. Okay. So mixture 30 and this is 35. Now what is happened? On, as you know, one hacker is also waiting for your key exchange because he just want to decrypt your data. He also knows dash and everything. Okay, but where is the problem? Where he is also lacking? He is lacking into the keys concept. Previously, we have used one concept, but he is also lacking into what concept here? Concept about keys there, right? So he is also looking for some solution. So he is waiting key. Okay, let's now see how it would happen. So we are using now one more securest method. So we are exchanging the mixture of key over the internet.
Excuse me, sir.
Yes, please.
Is 35 mix of side B, not A, sir.
Yeah, sorry. I have copy paste. This is side B. Clear? Now they would exchange mixtures with each other. They would exchange what? Mixture with each other. So this mixture would be on this side. Can I say, obviously, this is on this side. This mixture is again what? Sorry. This mixture of side A, that would be on the other side. Okay. In between, he is capturing it. So he has a mixture of side A. What is the mixture of side A? 30. And what is the mixture of side B? 35. Clear? On the both the side, we have mixtures. What happened now? In this mixture, side A would add its private key. What is the private key of side A? 20. So now 35, this is, it would add here. After this, 35 plus 20 would become what? 55.
Private key is 10.
Okay, private key is 10, sorry. Private key is 10. So 35. 20 plus 35, this is okay. So this is 10. So this would become what? 45. This is final calculation. The last calculation has come here. And how we have received this 45? 35 is a mixture of what? A plus B. Sorry, this is a private and public key of side B. And inside that I have added my private key. What is that? 10. So 35 plus 10 would become what? 45. So this 45 concept is known as now here. The number, just don't forget the number. This is what, 45? This concept, this final concept is known as here key. What is that? Keying material means collection of the keys. Collection of the keys. Same on this side. I have mixture of side A. This is 30. And let me add my, as a side B, let me add my private key. What is my private key? 15. So what would be the total mixture here? 45. The number is same or not? This is here. And this 45 and this 45 is same or not? Okay. So this is concept is known as keying material. What is that? Keying material. And now this is again here keying material. And on the both the sides, what we have the same keying material. How same keying material? Because this is 45 here and this is 45. And now onwards, let's consider this as your data. Okay, I have to encrypt it. Okay, so for the encryption, which algorithm I'm using here? Let's consider we have decided it's about dash or whatever. So algorithm is dash, but which keys would be required? Because without keys, algorithms are useless because that is method. Okay, so for that I need keys here. So I'll take one small crunch of the keys from where? From here. I have taken it from here. I'll use it. It would encrypt it. So on the another side, once it would be reached. Okay, so once happened, decryption is needed here. Which algorithm again? Dash only, and it would use the crunch from the test one. Okay, because this material and this is common. So earlier, you can see here, we have exchanged keying material, and this hacker right now is aware about only what? This here. And if he would try to add this 30 and 35, that would become what? 65. So don't you think key 65, 45, 45 is totally different. So this is one of the securest method which we use over the internet to exchange the keys, which is known as Diffie-Hellman. Clear? Don't go with this number. Okay, this is 65. Can we will remove 30 from here? That would become 35 something. Don't try to get a 45 here. Okay, because this is just a small number we are talking about here. But actually, it's not about small number. There would be wide range of number will be there. So one example I'll show you here. Hellman on. If you would check it here on Wikipedia, this method. Now see, this is a paint. Paint you cannot keep it separate, right? That is the number, the easiest method I have used. So see here, Alice and Bob, they are using common paint. The common keys we have decided. What keys we have decided? What was the number? The number was public key as a 20 here. So this is what? This is 20 and this is 20. Secret keys is known as private. So this is 10 and this is, I think, what we are using 15 over. They have mixed it. This is now mixture. So this mixture is 35 and this mixture is again, sorry, this is 30 and this is 35. This is a mixture exchanged. This is now public transport exchange. Okay, so now this is 35 here and this is 30 here. Added its secret key, which is what? 10, and then it would become 45. This is 30. Mixture of this is, and added this color is what? 15. Added 15 here. That again become 45. So on the both the sides now we have which common keys here. So this concept is known as symmetric key concept as well. This is one of the method of the symmetric keys. Symmetric keys, why I'm talking about? Because on the both the sides we have same keys now. And earlier there was a different private keys we was using for the encryption and decryption. Okay, because in the earlier method, as you know, as you can see here in this one, this is, I think I have used, yeah. So here I was using the public key of or B for the encryption, and here for decryption they are using what? It was using its private key. But if you have to send any data from here for encryption of the data, again you need the public key of what? A. So here encryption is happening with the help of public key of A, and here it's happening with the B. Both are the different or not? Clear or not? Both the sides has to maintain two different keys, three different keys actually. First on public key, private key, and the public key of the another side as well. Okay, so this is kind of, you can say, asymmetric key concept we have, but here we have common keys. So in the common keys method, this is one of the securest method here. Okay, so it's been, I think, 23 or 24 years. So this is one of the securest key exchange method. And once key exchange on the both the sides, whatever method you are using, that doesn't matter. If hacker is aware about the method, which method are you using it? Okay, no problem. What about the keys? Do you know the key? You are saying I can make the best key in the world. Okay, but the question is, if I'm also saying I also can make it, but that doesn't make any sense because you have your own recipe. Okay, I have the tea powder, sugar powder, milk, water, everything is common. Okay, but it's fine. But what about the recipes? There might be he or she is adding something extra into that, and I'm not aware about that. Clear? So this is all about the keys, which is known as the actual recipe for that dish. Clear? So here they have the same dish and the same taste on the both the sides, common, secret. Clear? So this is the concept about encryption. So in the hashing, which we would discuss tomorrow, hashing. In hashing, again, the keys would be required. So the same keys they would use for the hashing. Clear? Okay. So this is all about encryption over. Okay. So if you want to make it easy, so then use a number concept here, because then it's easy to add and okay, but don't try to subtract anything. But if someone is asking no, then how you can do that? Somehow let's consider one guy has subtract and add or something, and he also like made it what 45 at the place of what hacker. So then use the example of color. Okay, you just tell me if you would add 2 color, is that possible to make it separate again? Definitely not. Clear? Water, if you are adding a 2 cup of water, that's not possible. You can make it different, right? One is sweet water and second is the normal, not possible. Correct? It is the same solution. So this is the best example. If someone is not agreeing on your mathematics calculation, or in case if he is or she is able to understand, so that's fine. That is easy way to explain Diffie-Hellman exchange. Okay, or else you can practice with the test one. So Diffie-Hellman key exchange. So this is the which method? Key exchange here, because key exchange is the main concern in the encryption and hashing. So in cryptographic methods today, we have just discussed what? Only encryption. Encryption with Diffie. Okay, so tomorrow I will start with the hashing first. Okay, and then we have authentication. Okay, in that we have PSK and PKI. This PKI would take time. This would take almost 45 to 60 minutes. So tomorrow I'll try or not try, we have to finish these things. Okay, so tomorrow we have sufficient time. Okay, so tomorrow we will be able to finish it, and then Monday onwards, because tomorrow is the last class, Monday onwards we'll start with the practical of okay, the first practical, which is GRE. Okay, so Monday would be GRE and Tuesday would start with. So the next 10 classes would be almost for the IPC. Clear? So I think it's almost 10 o'clock. So I'm done. I cannot start anything right now. Any doubt, any questions? So along with this, we have completed one is site-to-site VPN, remote VPN, and policy-based VPN. Okay, so try to go through this theory. Online students, anyone, any doubt, any questions?
Sir, can you give
It's
me
clear.
one more example, sir, for Diffie-Hellman?
Some more. This is the only example. This is the only method we have.
Sir, if you don't mind, can you walk me through once again about the procedure, how it is exchanged?
Sorry, I didn't get it.
Sir, can you give me the summarize of how it is exchanged once again, sir?
So Diffie-Hellman is, first of all, site A and site B. So this is the common key. First of all, they would decide it on the common key. So what is the common key we have? Let's consider it's 20. And this is the common key again, we have 20. This is the private key, the secret key. Let's consider this side we have 15 and this side we have 10 here. They would add both. So 15 plus 20, 35, and 20 plus 10, 30. They would exchange it. So now we have 30 on this side and we have 35. So they are using public transport. They are using what? Public transport, means ISP, which is not secure. So we have 30 here and we have 35 on this. Then they would add its private key here. So 30 plus 15, that would be 45, and 35 plus 10. So that would be again 45. So 45 and 45. This is known as keying material. What is that? This is keying.
So this computation is to get private or public key, sir?
Sorry?
The 45 what we got, right? So both the parties will agree to it, right?
Yes. This is the key material.
This is a public key or the private key, sir?
This is common. This is the mixture of public, private. Okay. Overall, if you will see here, now see, this 35 is what? The common key and the private key of what? A. This is what? Sorry, this 30. This is the final 30. This is what? this 30, if I'll talk about the common key 20 and the private key of site B, which is what? 10. And after that, I have added my private key. So this is private key of site A. So which is what? 50. So this is mixture of all the keys here. Okay, keys of common keys and then private key of site A and the private key of site B. Clear?
Yes, sir.
Okay, so this is the keying material, the mixture, because we cannot exchange private keys directly over the internet. Okay, let's consider if you are trying key, okay, we have site A, site B, we have decided a common key 20, but I have a private key here 10 and I have 15. Let's exchange directly. No, because then the hackers would get to know, okay, they are exchanging their common keys 20, they are using 10 and then they're using 15. So what here? What you will do? This is 10 plus 20 is 30. This is my 15. It would add 45 here. So this is 12 plus 15, 35, and would add 10 into this 45. But along with that, this is also where about 45. So directly we cannot exchange. So this is the reason we are using the mixtures and then Diffie-Hellman concept into this. Because if they would try to exchange it directly, then that's not possible. Clear?
Yes, sir.
This is all internal process. We are not doing anything, right?
You even won't be able to capture anything, nothing. Okay, if you, because in the upcoming classes, once we'll start the practical, so we would be able to capture Diffie-Hellman packets, but inside that, what exactly there, you won't be able to see. Okay, so this thing cannot be captured and we cannot see. Just we have to assume it. Okay, because of this method, which is Diffie-Hellman. So this is the reason this is secure. If we are able to capture everything, then what's the meaning of the Diffie-Hellman there? Okay, so if we can capture anything, so we can see the keys and we can encrypt or decrypt any kind of data there. Clear?
For the encryption, dash, 3 dash, and AES, these are only the three.
In your syllabus, you have only these three. Otherwise, there are so many like encryption algorithms, so many. Okay, so these are the most popular one. Okay, and which we used. If we talk about, okay, you have to shop something, where you would check it first? Flipkart, Amazon, these are the 2-3 more popular, but if you would check, thousands of like shopping websites are there. Okay, so same like this. So these are the most popular one which we used over the internet. Okay. Yes, guys. Any other questions? Any doubts? If you want to get into its mathematical concepts and all, so this is some of the mathematical formulas and all. Okay, so you can get into this. Yeah.
Yes, sir. Please share the drivers, sir.
Yes, I have copied your already this one. One is Nawaz and second is Kalyan. 2 guys, right? I think so.
One more, maybe.
Ashwini is also there. Ashwini.
Yes.
Got it, guys. So I'll share the
And-
drive access within another 5 minutes with you guys. Okay.
Excuse me, sir.
Yes, please.
And also, sir, please share this AWS.
AWS.
Drive.
Correct.
Yes, please.
I'll share it. Don't worry.
Yes.
Okay.
Thank you, sir.
Thank you.
Have
Yes.
a good day, sir.
Yes. Any other guys? Any doubt? Any questions? Anyone?
Yes, sir. I have one more doubt, sir.
Yes, please.
You mentioned about HTTPS. So yes, we're going to specify that it is secured because of SSL, right?
Right.
So let's say I'm using LinkedIn. So they are giving me the public key. So whatever I am generating a traffic from my end to that website, so it will be encrypted with the key that is provided by them, right, sir? So they
Right.
will LinkedIn will going to use their private key to unlock. This is correct, right?
Have we discussed SSL VPN till now?
No, sir.
So then wait for that.
Okay.
Okay. So once I'll start it, then only I'll explain. Okay, so many other things are there. Right now, you're not aware about so many things. So this is not a point where I can explain SSL. First, IPsec and all. So for SSL, it would take minimum 22 to 25 days. Because first IPsec, after that only SSL. Okay, we right now CA-based VPN. You are not aware about certificate also. So there is so many things which is missing in between. So after that only I'll explain, not now.
Okay, sir.
Okay, so VPN October batch, right? This is October batch. Sorry for that, but once the time comes, then only I'll explain. Okay.
So tomorrow we have a class, right?
Yes, tomorrow we have class. Okay, same time, same link. Okay, and we'll finish all the cryptographic method, which is pending, integrity and authentication. Yeah, tomorrow might be you would get answer, not exact answer, but you like nearby, you would reach nearby. Okay. Kalyan, yesterday I think you have already shared your details in the AWS batch, if I'm not wrong, right? No. So then kindly, are you doing AWS batch or no? Like, are you attending it? No, I'm just asking if you're attending, so kindly share your details into the AWS batch, or else you can share it now. If you're already doing that batch, so then it's better to share the details in the batch itself, or else, okay, then share the details there only, okay? Because I have not shared that drive with anyone. Okay. So here this Nawaz, like he is not doing that batch because it's late night for him. So that's the reason he has requested for this. Okay. So, okay. So guys, then see you tomorrow. Okay. Bye-bye. Take care.
Thank you, sir. Have a good day. Thank you,
Yeah,
sir.
thank you.